Welcome, everybody. Today, I'm going to talk about a library called Lhotse. It's a speech data representation library for the modern deep learning ecosystem. Before I start, my name is Piotr Zelasko. I'm the head of research at Meaning, where we try to improve people's experience in voice communications. And without further ado, let's start. So, first, let's talk about what should you be getting out of this talk. I think there are three types of audiences for this. Audience number one doesn't work with speech, so why should they care about this library? Lhotse's main aim is to make speech data much more accessible, much more easy to work with. Historically, it's been a mess. A lot of people are complaining, even people in speech. And this is why we started this whole project, to make it much more accessible. If you're working on language, maybe you want to work on spoken language. If you're working on core AI deep learning, maybe you want to give your methods a run in audio and speech. Audience number two, they do work with speech, but they do use other tools already. So why should they care? If you're in this type of audience, give a look at Lhotse and please listen to the rest of the talk. You might find that it will simplify the data-related part of your work. We have a lot of features that will help you organize, augment the data, and optimize your data loading. And finally, there's the third type of audience who work with speech, and they completely understand that this gap about data exists today, and they completely understand why this library is built. If you're in that type of audience, well, I need to say nothing more. So let's start talking about Lhotse. It's actually a part of broader ecosystem of speech modeling tools. This is called the K2 ecosystem. This is an effort that started about 2 years ago and has a broad community, including academia, contributors from Johns Hopkins University, and from the industry, from companies such as Xiaomi or Meaning. What we are doing here is we are building a very modern ecosystem where you can leverage existing tools like PyTorch. And we basically fill in the gaps. We build some things related to computing objective functions, decoding for speech recognition, data handling, and finally, complete recipes. So you can see that all those libraries here, we're going to specifically focus on Lhotse. As I said, we want to make the data more accessible. We want to make it easy to work with, and we want to speed up your R&D. So let's do a technical deep dive, basic concepts from Lhotse. If you haven't worked with speech, you should know that the speech utterances, the speech recordings can be very long. Many of the data sets you would work with would actually be already cut into very short utterances. You can think sentences, you can think, for example, a phrase that I'm talking about. But more often than not, especially in actual real life deployments of different speech products, you're going to work with very long utterances, like the talk I'm giving right now. So we need to be able to represent that and work with that efficiently. The main abstraction is in Lhotse, the main three abstractions actually are recording, which is this whole long 10 minutes, 1 hour recording thing. A supervision, which might be, some piece of label, of annotation, of metadata that you have for this. It might be a transcript, might be a speaker identity for a given chunk of recording. Finally, there's cut. And cut is the thing that gives us flexibility how we want to transform this data into some training examples for our models. Here, you can see that the cut is exactly the same as supervision. The red boxes are exactly aligned with the green boxes, and they correspond to different turns in a conversation. So speaker A said, "Hi, Bob." Speaker B said, "Howdy, how's it going?" And so on. So this is a good data set for speech recognition. This is nicely transformed the data for speech recognition. But we can take exactly the same kind of data and we can reshape those cuts a little bit into fixed size boxes, which have both speech and non-speech segments. And this is a perfect transformation for voice activity detection training. So we're trying to answer the question, is who spoke when, or when is there speech and when there is not. Cuts have a very pleasant to use API. You can actually use them in Jupyter notebooks, and you can plot the audio. You can play the audio to listen to it. You can apply different transforms, such as truncate the audio, pad it with some silence, mix it with some other audio chunk, or you can compute the features. You can do all of that interactively. And the most important thing, those operations are lazy and composable. So nothing actually happens before you actually load the data into memory, which is very nice. It's nice optimization for efficiency. You can work with collections of data. So we had a single cut for, let's say, a single utterance. Now we have a whole cut set for a collection of those examples. And again, we have a lot of composable lazy operations. To be honest, this design is inspired by Pandas data frames, which I always felt are really missing, like equivalent of them is really missing for speech. Again, you can do all of these operations like data augmentation, resampling, changing the speed, sorting, and so on. In terms of implementation, this is actually very lightweight, and the Python classes have direct correspondence to a JSON-L manifest representation. This is very handy if you want to actually keep this in some file database, S3, wherever. We have currently 50 recipes for publicly available speech data sets, different languages, different types of tasks. Basically, you don't need to do a lot of that pre-processing or data preparation kind of thing, which nobody really likes to do. So let's very briefly talk about Lhotse for deep learning workflows, specifically about Lhotse's integration with PyTorch. First, let's start with some concepts. As I told you, there are different lengths of utterances. Even if we deal with short utterances, this could be a 3-word utterance, a 5-word utterance, a 20-word phrase. They will be very different in duration. People who work with NLP understand this problem well. They have examples, for example, for classification, which have different transcriptions of different size. And if we just pack them into mini batches without giving it any serious thought, we will end up with wasting a lot of GPU resources. So Lhotse provides some utilities to help amend that issue. This technique you can see here, this is usually referred to as bucketing. So Lhotse implements several PyTorch samplers, such as the bucketing sampler. This bucketing usually is done in some pre-computed way. In Lhotse, you can actually do it on the fly with minimal memory usage, just keeping some small buffer. So you can work with actually very, very large data sets and still leverage those techniques. On the other hand, this is something very specific to speech. Sometimes you might want to include some extra acoustic context. Let's say you're training some models for speech where you want to involve a broader context, several phrases, maybe several speakers. With utilities in Lhotse, you're able to still represent that in a mini batch. This is something really new. This is something that I have not seen in any other speech toolkit before. So let's take a look at how you would deal with all of that when writing code. It's actually pretty simple. It's very, very, very similar to standard PyTorch workflows. You define a PyTorch data loader, which takes a data set and a sampler class. The sampler class is going to pack those cuts to mini batches based on metadata. The data set is actually going to do the data IO, transformation, feature computation, and so on. One important thing to note is that we support dynamic batch sizes. So the batch size is not necessarily a fixed number of items. It may be determined based on the total duration of speech examples. This is something very handy in practice for things like speech recognition. The sampler actually owns the metadata. This is a little bit different from how things are often handled in PyTorch datasets, but it's a technicality. And then when you train your models, it's business as usual. If you already had a model, a training loop, and so on, you don't need to change literally anything. So you might ask, how does it work with multi-GPU and distributed training? It works out of the box pretty much. You don't need to tweak a lot. So by now you should have a nice overview of Lhotse. If you're interested, please try us out. You can install Lhotse from pip. There's plenty of materials you can learn more from. You can visit us at GitHub. You can read the documentation. There's a NeurIPS Data-Centric AI workshop paper from last year that you might want to read. There's also a 3-hour-long InterSpeech 2021 tutorial about the broader K2 ecosystem, which if you found this talk interesting, you will definitely want to check out. Well, enjoy working with speech data. Thank you for your attention and see you on the summit.